Results have shown that our sun is 91 million miles away from us, yet even from this distance, the star has an amazing impact on humanity. Scientists have always been fascinated by the sun and have always been inquisitive towards it. We know how hot it is and how large it is, but we don't have much information on why it acts the way it does. Join us in this video today as we explore some of the wonders of the sun. Anything that gets so close to the sun, even if it's a million miles away, is destined to be burnt. That's why the Parker Solar Probe from NASA is very popular. The probe is not only getting so close to the sun, but it also sends down information to us to give us some idea of how the star works. The Parker Solar Probe is the first man-made object to touch the sun's outer layer. Also, recent findings from the mission seem to have left NASA with confusion. Let's take a look into the Parker Solar Probe, shall we? The Parker Solar Probe was launched from Cape Canaveral on August 12, 2018. This probe had one goal, which is to make 24 close-ups as it orbits the star and study the sun's atmosphere, known as the corona. Presently, probe is doing its work, flying by the sun in imaginable ways. The probe is 3.7 million miles away from the sun, which is the closest any craft has ever come across. In fact, it is 8 times closer than any previous spacecraft and nearly 9 times closer than the planet Mercury. Now, you may ask, what is the purpose of the probe, aside from breaking huge records, of course? It was made to study heat and energy from the sun and how they move through the corona. Parker was invented to study the solar winds that come from the sun's surface, to see what speeds them and where they come from. To understand better, the Parker Solar Probe was there to answer our numerous questions about the sun, solar physics, and solar winds that scientists have been asking for over 50 years. Back in the 1950s, a probe like this was proposed. But, as you know, science had not matched the aspirations of scientists, and there was no way to create a spacecraft that could withstand the heat from the sun. It is the solar winds that are the main purpose of Parker's mission. Solar winds are the collection of charged particles which streams from the sun and flows past Earth at the speeds of more than 1 million miles per hour, or 1.6 million kilometers per hour. These winds have the possibility of affecting our planet's magnetic field and create something known as space weather. Space weather is the energy that moves throughout the space and can impact or destroy our satellites. Our man-made satellites are very important for humanity, empowering almost everything from cell phones to television to weather reports and plane trips. With this, you may have some understanding of why studying solar winds and space weather is very important. One of the wildest things about solar winds is that there is no accurate cause for them. There is no wind close to the sun's surface, but they are somehow ejected from it. Note that the sun is not like Earth, as it doesn't have a solid surface. Rather, the sun is a molten churning mass of burning heat that is kept together by the gravitational force. The sun is so large and dense that anything so close to it is grabbed by it. Despite this, the solar winds are able to escape from the sun's gravity and then build speed that allows them to move through space, millions of miles per hour. Scientists believe that there is an unknown factor accelerating these massive waves of wind, and the Parker probe is available to find out exactly what it is. There are also questions about the sun's corona, which is also another thing that the Parker probe is investigating. The corona is basically the atmosphere of the sun. It has an astonishing wide radius that reaches out millions of miles. The area where the sun sucks in gravity and the magnetic field around it is called the Alpha critical surface. Scientists are aware of this black hole, but till date, they can't figure out how far from the sun it travels. Recently, scientists have thought that the critical surface was somewhere in between 4.3 to 8.6 million miles away from the surface of the sun, or about 10 or 20 times its radius. As we have it, Parker probe has shown that it's about 8.1 million miles away from the sun. Parker is looking into the corona because this is where we would learn mostly about solar winds flowing from the star's surface. Parker revealed that the corona isn't just a smooth circle around the sun, but it has a series of huge spikes and valleys. This information is a huge step to understanding what instigates the solar winds. Despite being millions of miles away from the surface, the Parker probe cannot spend much time being this close. The reason is that the corona is also extremely hot. In fact, for some reason, the corona is actually hotter than the sun's surface. The corona is 1 million degrees Kelvin, or 1.8 million degrees Fahrenheit, while the sun's surface is only 6,000 kelvins. At this point, you may begin to ask, why is the corona around the sun hotter than its surface? It is another question that the Parker probe is trying to answer. Even with a 4.5-inch thick carbon composite solar shield, the probe has to be careful with the corona. This is the reason why it is completing its mission on a series of large swoops that it brings in close and back again to safety. By the time Parker finishes its journey in 2024, it would have made around 21 close approaches toward the Sun for over 7 years. As its nearest flyby, the probe will orbit within 3.9 million miles of the Sun's surface. Scientists compare that to being on the 4th yard line of the football field, while the Sun rests on the end zone. It is that close. The Parker probe would also be close to the Sun during an important time of its 11-year cycle. Every 11 years, our star completes a solar cycle of calm and stormy activity, and then begins a new one. The Parker probe would be able to understand the Sun's cycle better, which has different effects on solar winds and everything else related to our Sun. The current solar cycle is why we started in December 2019 and will hit the climax in July 2025, which means Parker would see it till the end. Even with all the hard work Parker has been commencing, there will be several mysteries about the Sun, which means probably Parker won't be the only one sent by NASA. Also, the information gotten from the Parker is still giving us so much idea on how the Sun works. From the looks of things, NASA keeps pushing the limits beyond possibilities, and the same thing can be said about their newest invention, the James Webb Telescope. The James Webb Space Telescope is a space telescope and also an international collaboration among NASA, the European Space Agency, and the Canadian Space Agency. It was created with the intention for it to succeed the Hubble Space Telescope. The James Webb Space Telescope was launched on the 25th of December in 2021 on Arani Flight VA256. It is crafted to provide improved infrared resolution and sensitivity over Hubble, viewing objects up to 100 times fainter than the faintest objects found by Hubble. This will allow a broad range of investigations across the fields of astronomy and cosmology. JWST's primary mirror, the optical telescope element, is made up of 18 hexagonal mirror segments made of gold-plated beryllium, which comes together to create a 6.5 meter, or 21 feet, diameter mirror. This gives Webb's telescope a light collecting area about 5.6 times as large as Hubble's 2.4 meter, 7.9 feet, mirror. Unlike Hubble, which observes it in the nearest ultraviolet visible and near-infrared spectra, JWST will observe it in a much lower frequency range, from long wavelength visible light, red, through mid-infrared, 0.6, to 28.3 UM. This will enable it to observe high redshift objects that are too old and distant for Hubble. The telescope must be kept below 50 K, or -223 Celsius, or -370 Fahrenheit, to observe faint signals of the infrared without involvement from any other source of warmth, so it will be deployed in space near the Sun-Earth L2 Lagrange point, which is a point in space about 1.5 million kilometers, or 930,000 miles, from Earth. This is where its 5 layers of kite-shaped sun shield can protect it from warming by the Sun, Earth, and Moon at the same time. This is indeed fascinating. That's all for today. If you would like to learn more about outer space, please subscribe to the channel. And if you loved this video, give it some thumbs up.